Good day, my super research students. I hope we're all good today. All right, thanks be to God. Okay, remember last class we said we'll be doing some calculations today. We'll be going back to this procedure and tools for data analysis, where we'll be talking about the frequency table, the charts, the measures of central tendency, talking about the mean, median, and mode, and all the rest of them. Okay? All right. Procedure and tools for data analysis. In data analysis, there are procedures and tools to be employed depending on the type of research as well as the nature of the data to be analyzed. Regardless of the instruments or methods used in data collection and whether the data is from sample or population, the first step in data analysis is to describe the collected data. You have to describe the data you have collected in order to be able to analyze it. To do this, however, the data should be summarized either using a frequency table or chart. When you summarize the data, it is easier understood. Anybody can look at it and be able to interpret it and understand what you were talking about. So you summarize it. Either you use a frequency table or you use a chart. These two are veritable tools for presenting and communicating data in such writings as technical reports and journal articles. So we are going to be looking at this frequency table and the charts. The frequency table. There is no doubt. Okay, let's put it down first. Tools for data analysis. You have the frequency table, and you have the charts. Okay, there is no doubt that with the frequency table, the researcher can display the number of cases which have each of the attributes of a variable. It also serves to display both qualitative and quantitative data. When confronted with the number of attributes or categories of a variable that is too large, the frequency table adopts the grouped data approach by combining the attributes into classes. E.g., with age as a variable, the frequency table may represent data as, you look at this data now, you have 20 to 24, 25 to 29, 30 to 34, 35 to 39, 40 to 44. Now we're going to break it down to show you how frequency table can really help you to present your data in a good form. Let's look at this. You're talking about age as a variable. That's an example. Age as a variable. Let's look at the frequency table. Now let's say you have let's take for instance you have various ages. You have like 20, 25, 40, 35, 36, 26, 38, 44, 28, 29, 30, 33, 32, 40, 35, 38, 39, 42, 60. No, we don't have 60 there. 27, 23. Okay, let's just end it here. Now, if you have a large number of data, remember, if you're working on a research, you won't just have data as little as this. It's going to be so many of them. We're just going to use this as an example. When you have this, you don't have to start counting 20, 36, 35, one after the other. It's going to make your work very clumsy. So what we do is to get a frequency table. You get a frequency table. These are your ages. This is age, and this is frequency. Okay. When the data is so much, we put it in form of a range. For age 20 to 24, 20 to 24, you have 25 to 29, 30 to 34, 35 to 39, and you have 40 to 44. Okay, now looking at this 20 to 24, you pick the ages that fall within this range. Here you have 20, that is 1, 20, that is 2, 20 to 24, that is, you have just 2, frequency of 2. For 25 to 29, you have 25 1, 26 2, 28 3, 29 4, 23 5, frequency of 5. For 30 to 34, you have, let us see, 33, 32, that is frequency of 2. For 35 to 39, you have 1, 2, 36 is 2, 38 3, 35 to 39, this is 4, 5, 6. You have a frequency of 6. And then for 40 to 44, we have 1, 2, 3, 4, frequency of 4. Now you're going to have your total frequency here. Total frequency. A total frequency is going to be the sum of all the frequencies. We have 2 plus 4, 2 plus 5 is 7. 7 plus 2 is 9. 9 plus 6 is 15. 15 plus 4 is 19. So you're going to have a total frequency of 19. Now, let's count these figures. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Alright, that means we've made a mistake somewhere. Let's look at it again. 20 to 24, 1, 2, to 24. That is, 3. 23 is within the range of 24. So you see why frequency table is very important. At the end of the day, you're supposed to have the same number of data as what you have as your total frequency. So this is what a frequency table looks like. Instead of going to check your data one after the other to find out in order to analyze it, you simply group it. Age range of 20 to 24, we have 3 different ages. 25 to 29, we have 5. 30 to 34, we have 2. 35 to 39, we have 6. And 40 to 44, we have 4. So the total frequency is 19. So this is just what frequency table is all about. We've just used the example here to fix that frequency table. All right, we move over to the charts. The charts, just like the frequency tables, there are also charts which serve similar purposes. The 2 most commonly used charts are the pie and bar charts. Pie and bar charts. Let's look at it. The charts, let's put it on that chart. We have A, pie chart. And B, bar charts. Okay. That is, both could be used to present data summaries and also used to interpret and convey the message more quickly. Concisely and clearly than frequency table. So looking at your bar chart or your pie chart, it helps, once you look at it, it helps you to understand the message being passed across more than frequency table. You know, frequency table has to do with figures, but this one is like a picture. When you look at the picture, the pie is in the shape of a pie, circular shape, and then bar charts in shape of bars. You have your chocolate bars and so on. So when you look at them, just then looking at them, it will help you will understand the message more quickly. The last class I told you about teaching children with pictures. When you show them pictures, it sticks to their memory, helps them to understand better. The same thing applies to this pie and bar chart. You don't have to, unlike the frequency table where you work with figures and figures, here you just look at it. If you're using a pie chart, the sector, like we said, the pie is in form of a circle. So the sector of the circle, the size of the sector will tell you the size of each data group. The same thing with the bar charts. The size of the bar, the height of the bar will tell you that. Okay. Their great limitation, however, lies in the fact that they hardly cope in situations where the attributes of a variable to display are too many, especially when these are more than 9. You can see that in our frequency table, no matter how many they are, the highest thing, you just group them. When you group them, you still have everything together. But in a pie chart, the space is limited to that circle. And the more the number of data, the smaller the sector of the circle. It will show you a smaller sector. And when the sectors begin to get too tiny, you will not be able to get the right picture you need. The same thing applies to bar charts. So this is just the limitation that they have. This is particularly so for pie charts, which are quite useful in providing vivid picture of data, but only in showing the distribution of variables with single responses. Thus, they are inappropriate tools for variables associated with multiple responses from the units of the study. If you get your questionnaire and you have so many responses from so many respondents, using a pie chart will not be the right thing because it has its limitations. Okay. Also, while they are most applicable for qualitative data, pie charts also serve to display quantitative data, particularly those whose number of attributes or categories is not more than 5. As for the bar charts, they serve for qualitative data in particular, irrespective of the nature of the responses to the variables, either single or multiple. Since bar charts make it easier to compare the categories of a variable, they are more suitable for displaying data with more than 5 categories. They also serve to display quantitative data, particularly the variable presented in a discrete fashion. However, histogram remains the more appropriate tool for displaying continuous variables. We talked about histogram the last time. It remains the more appropriate tool. Okay. Measures of central tendency. This is another approach to describing a set of data, considered useful in determining a typical attribute or value of a variable. The measure is also useful in comparing the performances of 2 or more groups or the performance of a group over 2 or more periods of time. The mean, median, and mode are the 3 most common measures of central tendency. The mean, the median, and the mode. Let's take it down again. Measures of central tendency. You have 1, the mean, the median, and mode. The mean is the arithmetic average of a set of data, usually applicable to quantitative data. To obtain the mean, you sum up all the scores in a set of data to be divided by the number of scores. With the distribution of the variable that is skewed, however, the median will better represent the distribution, as extreme values tend to increase or decrease the mean. If we look at the mean, let's still use these figures we used, assuming we are to find the mean. Okay, we said to get the mean, you sum up all the scores in the set of data and you divide by the number of scores. Let's take the mean of those scores here. Mean. Sum of scores divided by number of scores. Sum of scores over number of scores. Here we have, we corrected this and we have 19, right? This is 3 plus 5 is 8, plus 2, 10, plus 6, 16, plus 4, 20. So our frequency here is 20. Total frequency. Okay. So assuming we are to take the mean of this, we said The mean is the sum of scores over number of scores. The sum of scores here is 20. But you know, when you're solving, you don't just write 20, you have to show your full working. So we're going to have sum of scores as 3 plus 5 plus 2 plus 6 plus 4. 3 plus 5 plus 2 plus 6 plus 4, which will give us 20, because you have to show how you got your 20. That is sum of scores. Sum of scores. Then you have number of scores. Number of scores. Number of scores is just the number you have here. How many of them? You have 1, 2, 3, 4, 5. We have 5. I'm just using these figures to show you how to calculate your mean. Now, sum of scores over number of scores. Our sum of scores is 20 and our number of scores is 5. Therefore, mean will be 20 divided by 5, which will give us what? 4. So the mean will be 4. So this is just how to solve your mean. Alright, we go to median. The median is considered as the middle value in a set of data. Median. When I talk of median, I'm talking of middle. Gotten from the word middle, refers to what is in the middle. So it's considered as the middle value in a set of data when all the values are arranged in order of magnitude. Please take note of that. The data, the values must first of all be arranged in order of magnitude before you begin to look for what is in the middle. In other words, the median tends to show the grouping together of scores around a central point, middle, central point, how the scores are grouped together around that central point, dividing a set of data into two main parts. In short, the middle scores between the upper half and the lower half is the median. So when you divide your set of data into two main parts, the upper part and the lower part, the upper part has to be equal to the lower part. Then you now look at what you have in the middle. That is your median. Although the median is most appropriate for ordinal data, it is also applicable to ordinal, interval, and ratio data. Okay, let's take a little example again on the median. Median. Let's just take different figures. Let's say 6, 1, 2, 3, 4. Let's take another 4. Let's say 2 again. 7, 9, 8. Let's look at this. Median. If we want to get the median, we firstly arrange them in order of magnitude. That is from the lowest to the highest. The lowest number here is 1. Then you have 2. You have another 2. Look at it. You don't just say, oh, we have 2 already, and then you write just 1. No. It doesn't matter how many they are. You must have to write all of them together. Still in order of magnitude, we have 3, 4, another 4, we have 6, we have 7, we have 8, and we have 9. So looking at those numbers, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10 numbers. That means 5 to the left and 5 to the right. Okay, you see 1, 2, 3, 4, 5. From this first one to this is 5. These are 5. And then we have 1, 2, 3, 4, 5. Now, if you look at these two numbers, you have nothing, there's no single number in the middle. So what you do is, you pick these two, 4 and 4, that are in the middle. What you do is, if you have two numbers in the middle, you find the mean of those two numbers. The mean of those two numbers. The mean of this number, remember from our formula for getting mean, is the sum of scores over number of scores. So we are going to get the sum of these two numbers in the middle over their number. The sum is just 4 plus 4, which will give us what? 8. How many are they? They are just two numbers. So they are not that the number of scores here is 2. So the mean of this is going to be 8 over 2, which will give us 4. So you see that the median of these figures is 4. Now, assuming we had 11 digits, let's say we still have the same. Let's pick them already arranged. 2, 2, 3, 4, 4, 6, 7, 8, 9. Now, looking at these numbers, you have an even set of numbers. There are 10 in number. 10 is an even number. That's why we had 2 middle numbers. No middle number exactly, but we now picked these 2 that are at the center, and we found the mean. Assuming we have an odd set of numbers, let's say we have 11, we have 16, and we have 18. How many numbers do we have now? That will make it 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 is an odd number. So we are definitely going to have one number in the middle. 13, that will be 6 to the left and 6 to the right. 1, 2, 3, 4, 5, 6 to the left. 1, 2, 3, 4, 5, 6 to the right. Have you seen it? Okay. That means we have 6 in the middle. We have just one number in the middle. So in this case, the median is just simply 6. But in this other case, when the number of data is an even number, we pick the two numbers in the middle. Okay, that is about the median. We move to the next one, which is the mode. The mode. Meanwhile, the score which has the largest frequency in a set of data is referred to as the mode. Take note of this: largest frequency, not necessarily the one that is higher in size, not the largest in size, but the largest in frequency. That figure could be the lowest number, but for the fact that it has the highest frequency, it becomes the mode. So the score which has the highest frequency in a set of data is referred to as the mode. It refers to the most common attribute or value of a variable, in which case it is possible for a set of data to have more than one mode. When a set of data has more than one mode, it is still possible for a set of data to have more than one mode. If you have two modes, you can call it a bimodal. Let's say it's bimodal. If you have three, trimodal, and so on. Although most appropriate for nominal data, the mode is also applicable to all types of data. It's more appropriate for nominal data, but it's also applicable to every other type of data. Measures of variability. This is also known as the measures of dispersion, in which a measure of variation and dispersion is calculated primarily to determine the homogeneity of a set of data. There are separate measures of variation for qualitative and quantitative data. For qualitative data, measures of variation include range, standard deviation, variance or the square of standard deviation, coefficient of variation. Now, before we go into these measures of variability, let's do a little thing on mode. Let's do a little work on mode. We've worked on the mean, we've worked on frequency, we've worked on mean, we've worked on median. So let's get to mode. Let's go back to automatic. All right. Let's take some figures. Let's say 2, 3, 4, 2, 7, 3, 9, 7, 2, 8, 2, 2, 3, 2, 4. Let's just stop here. Okay, if we look at this, 2 has a frequency of 1, 2, 3, 4, 5, 6. Frequency of 6. 3 Let me use equals so that it doesn't look like minus 6. 3 has a frequency of 1, 2, 3. 4 has a frequency of 1, 2. Okay, let's bring this down to the next page for easier understanding. Okay, then you have the next number, 7 has a frequency of 1, 2, that is 2. We've done 2, 3, 4. Yes, the next is 9. 9 has a frequency of 1. After 9, we've done 7, 2, we have 8. 8 has a frequency of 1. Alright, now looking at all the frequencies, you can see that, like we said, it's not about the size of the number. It's about the frequency, how often it has occurred. So looking at 2, 2 happens to be the smallest number there. That's the least, but it has the highest frequency. So the highest frequency, since it has the highest frequency, okay, look at 9. Even though 9 is the highest number there, but it has the lowest frequency, the 9 and the 8. Okay, so since 2 has the highest frequency of 6, see 2 becomes the mode. Mode equals 2. Okay, let's look at an issue, a situation where you have more than one mode. You can still pick these figures. Let's just copy and paste them rather than wasting the time. Alright, we have these numbers, still the same thing, but we want to increase the numbers to be able to get a situation where we can have more than one mode. We can still add 1. Assuming we have 4 is already with a frequency of 2. We need 4 more 4s. 3, 4. Assuming your data is like this. So instead of 4 to have a frequency of 2 this time, with the additional 4, 4 is having a frequency of 6. So if 2 has a frequency of 6 and 4 has a frequency of 6, that means both of them have the same frequency. So both of them are the mode. Both of them have the same frequency and both of them have the highest frequency. So in this situation, we say that this is bimodal. It is bimodal. Bi refers to 2. Bicycle, that is 2 cycles. A bicycle has 2 cycles. So when you hear bi, it means 2. So bimodal simply means 2 modes. So you can see in this case that you have 2 with a frequency of 6, 4 with a frequency of 6. So it is 2 modes in this data. So it is bimodal. So mode can be 1, it can be 2, it can even be 3, depending on your range of data, depending on the data you have collected. So that is about mode. Alright, having looked at the mean, the median, and the mode, let's go through this measures of dispersion. We have separate measures of variation for quantitative and qualitative data. For the quantitative data, we have the measures of variation. We have the range, standard deviation, variance, or the square of the standard deviation. Variance or square. When you square the standard deviation, you're going to get variance. And then you have the coefficient of variation, the range, the standard deviation, the variance or square of standard deviation, and then the coefficient of variation. Let's put it down. Measures of variation for quantitative data. We have one, the range. We have the standard deviation. The variance. And the variance, we said, when you square the standard deviation, you get your variance. That's standard deviation multiplied by itself. That is the square. That is when you get your variance. So you can say variance or square of standard deviation. Variance or square of standard deviation. Then the next one is coefficient of variation. Coefficient of variation. So these are the 4 measures of variation for quantitative data. All right. So next class, we are going to take them in details once again. When you're doing calculative work, you don't have to cloud yourself with so much of them. I want you to take it one after the other. We have done the mean, the frequency table today, the mean, the median, and the mode. Next class, we are going to go into the range, the standard deviation, the variance, and then coefficient of variation. All right. So that will be done the next class. Thank you very much. Have a wonderful day and keep going through your work. Research is a very, very, very interesting course. Have a blessed and wonderful day. Bye.